Southwire Company, an American manufacturer of electrical wire and cable, has announced its intention to acquire Essex Electrical Products, a subsidiary of Outcore International. The acquisition is expected to close in the second quarter of 2023, subject to customary closing conditions and regulatory approvals. This acquisition is significant for several reasons. Firstly, it involves the expansion of domestic manufacturing. Southwire has a strong commitment to American manufacturing, and this acquisition will further enhance its domestic production capabilities. Essex Electrical Products operates multiple manufacturing facilities in the United States, including in Kentucky, Ohio, and Texas. Secondly, it involves a complementary product portfolio. Essex Electrical Products specializes in the production of a wide range of electrical products, including wire and cable, conduit, and fittings. These products complement Southwire's existing portfolio and will allow the company to offer a more comprehensive range of solutions to its customers. Thirdly, increase market share. The acquisition will significantly increase Southwire's market share in the electrical industry. Essex Electrical Products is a leading supplier of electrical products in the United States, with a strong customer base across various markets. Fourthly, a positive impact on the American economy. The acquisition is expected to have a positive impact on the American economy. It will support the growth of domestic manufacturing, create new jobs, and contribute to the overall competitiveness of the U.S. electrical industry. The acquisition of Essex Electrical Products by Southwire is a testament to the company's commitment to American manufacturing and its pursuit of growth and innovation. This strategic move will allow Southwire to expand its product offerings, increase its market share, and further contribute to the success of the electrical industry in the United States. Electrical wire and cable are essential components in a wide range of applications, from residential wiring to industrial power distribution. Understanding the different types of wire and cable, their properties, and their appropriate uses is crucial for electrical engineers, electricians, and anyone working with electrical systems. Electrical wire is a single conductor, while electrical cable consists of two or more conductors insulated from each other and enclosed in a common jacket. The conductors are typically made of copper or aluminum, chosen for their conductivity and cost-effectiveness. Copper has higher conductivity and is more ductile than aluminum, but aluminum is lighter and less expensive. Insulation is a non-conductive material that surrounds the conductor to prevent current leakage and protect against electrical shock. Common insulation materials include polyvinyl chloride, polyethylene, and rubber. The voltage rating of a wire or cable indicates the maximum voltage that it can safely handle. It's important to select a wire or cable with a voltage rating that is appropriate for the application. The ampacity of a wire or cable is the maximum amount of current that it can carry without overheating. Ampacity is determined by the size of the conductor, the insulation material, and the ambient temperature. The National Electrical Code, or NEC, provides guidelines for determining the ampacity of wires and cables in different conditions. Different types of wires and cables are designed for specific applications. Some common types include non-metallic, or NM cable, which is commonly used for residential wiring; underground feeder, or UF cable, which is designed for direct burial in the ground; THHN or THWN wire, which is used in conduit for commercial and industrial applications; and finally, armored cable, which is used in locations where physical protection is required. When selecting wire or cable, consider the following factors. Firstly, the voltage and current requirements of the application. Secondly, the environmental conditions such as temperature, moisture, and exposure to chemicals. Thirdly, the insulation requirements, such as the need for conduit or direct burial. Fourthly, the applicable codes and standards, such as the NEC. Proper installation of electrical wire and cable is essential for safety and reliability. Follow these guidelines. Firstly, always disconnect the power before working on electrical circuits. Secondly, use the correct tools and techniques for stripping, splicing, and terminating wires. Thirdly, support and protect wires and cables to prevent damage. Fourthly, properly ground all electrical equipment. And finally, inspect wiring regularly for signs of wear or damage. Electrical conduit is a protective tubing system used to route and protect electrical wiring. Conduit provides mechanical protection for wires and cables, protects against moisture and corrosion, and prevents the spread of fire. Several types of electrical conduit are available, each with its own advantages and disadvantages. Rigid metal conduit, or RMC, is a heavy-duty steel conduit that provides excellent protection against physical damage and corrosion. Intermediate metal conduit, or IMC, is a lighter-weight steel conduit that offers similar protection to RMC but is easier to install. Electrical metallic tubing, or IMT, is a thin-walled steel conduit that is lightweight and easy to bend. Flexible metal conduit, or FMC, is a flexible conduit that is used in locations where movement or vibration is present. Rigid polyvinyl chloride, or PVC conduit, is a non-metallic conduit that is resistant to corrosion and chemicals. When selecting electrical conduit, consider the following factors. Firstly, the type of wiring being used. Secondly, the environmental conditions. Thirdly, the degree of physical protection required. Fourthly, the applicable codes and standards. Proper installation of electrical conduit is essential for safety and reliability. Follow these guidelines. Firstly, use the correct tools and techniques for cutting, bending, and threading conduit. Secondly, support conduit properly to prevent sagging or damage. Thirdly, seal conduit fittings to prevent moisture from entering. Fourthly, ground metal conduit to provide a path for fault current. And finally, inspect conduit regularly for signs of damage or corrosion. Electrical boxes are enclosures used to house electrical connections such as switches, receptacles, and splices. Electrical boxes provide a safe and convenient way to access and work on electrical wiring. Several types of electrical boxes are available, each designed for specific applications. Outlet boxes are used to mount switches, receptacles, and lighting fixtures. Junction boxes are used to splice wires together. Pull boxes are used to provide access for pulling wires through conduit runs. Weatherproof boxes are used in outdoor locations to protect electrical connections from moisture. When selecting electrical boxes, consider the following factors. Firstly, the number and size of wires being connected. Secondly, the type of wiring being used. Thirdly, the location of the box, whether indoor or outdoor. Fourthly, the applicable codes and standards. Proper installation of electrical boxes is essential for safety and reliability. Follow these guidelines. Firstly, choose the correct size and type of box for the application. Secondly, secure the box firmly to the wall or ceiling. Thirdly, use cable clamps or connectors to secure wires to the box. Fourthly, ground metal boxes to provide a path for fault current. And finally, cover all boxes with a cover plate. Electrical connectors are used to join wires together and to connect wires to electrical devices. Electrical connectors must provide a secure and reliable connection to prevent loose connections, which can cause overheating and fires. Several types of electrical connectors are available, each designed for specific applications. Wire connectors, such as wire nuts and crimp connectors, are used to splice wires together. Terminal blocks are used to connect wires to electrical devices, such as switches and circuit breakers. Lugs are used to connect wires to equipment, such as transformers and motors. When selecting electrical connectors, consider the following factors. Firstly, the size and type of wire being connected. Secondly, the voltage and current rating of the connector. Thirdly, the environmental conditions. Fourthly, the applicable codes and standards. Proper installation of electrical connectors is essential for safety and reliability. Follow these guidelines. Firstly, use the correct tools and techniques for stripping and crimping wires. Secondly, tighten connectors securely to ensure a good connection. Thirdly, insulate all connections properly to prevent short circuits. And finally, inspect connections regularly for signs of looseness or corrosion. Grounding is the process of connecting electrical equipment and wiring to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and prevent fires. A grounding system consists of a grounding electrode, such as the ground rod or water pipe, a grounding conductor which connects the equipment to the grounding electrode, and a bonding conductor which connects metal parts of the electrical system together. Grounding is essential for safety in electrical systems. It provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers and clear faults quickly. This reduces the risk of electrical shock and fire. The NEC provides detailed requirements for grounding electrical systems. These requirements cover the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metal parts. Follow these guidelines to ensure proper grounding. Firstly, install a grounding electrode that meets the requirements of the NEC. Secondly, connect the grounding electrode to the service equipment with a grounding electrode conductor. Thirdly, bond all metal parts of the electrical system together with bonding conductors. Fourthly, ground all electrical equipment to the grounding system. And finally, inspect the grounding system regularly to ensure that it is in good condition. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a safe level, which prevents damage to equipment and reduces the risk of fire. Circuit breakers are reusable overcurrent protection devices that trip open when an overload or short circuit occurs. Fuses are single-use overcurrent protection devices that melt and break the circuit when an overload or short circuit occurs. The NEC provides requirements for the selection and installation of overcurrent protection devices. These requirements cover the size of the overcurrent protection device, the type of overcurrent protection device, and the location of the overcurrent protection device. Follow these guidelines to ensure proper overcurrent protection. Firstly, select an overcurrent protection device that is sized appropriately for the circuit it is protecting. Secondly, use the correct type of overcurrent protection device for the application. Thirdly, install overcurrent protection devices in readily accessible locations. Fourthly, protect overcurrent protection devices from damage. And finally, inspect overcurrent protection devices regularly to ensure that they are in good condition. Electrical safety is paramount when working with electrical systems. Electrical shock can cause serious injury or death. Electrical fires can cause extensive damage to property. Always follow these safety precautions when working with electricity. Firstly, disconnect the power before working on any electrical circuit. Secondly, use insulated tools and equipment. Thirdly, wear appropriate personal protective equipment, such as gloves and safety glasses. Fourthly, never work on electrical circuits in wet conditions. Fifthly, inspect electrical equipment regularly for signs of damage. Sixthly, follow all applicable codes and standards. Seventhly, if you are not qualified to work on electrical systems, hire a qualified electrician. Eighthly, be aware of the hazards of electricity and take steps to protect yourself and others. Ninthly, never overload electrical circuits. Tenthly, use ground fault circuit interrupters or GFCIs in wet locations. And 11thly, test electrical circuits before working on them. Electrical codes and standards provide guidelines for the safe installation and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE. The NEC is the most widely used electrical code in the United States. It provides comprehensive requirements for the installation of electrical systems in buildings. Electrical codes and standards are constantly evolving to keep pace with new technologies and changing safety requirements. It is important to stay up to date on the latest codes and standards to ensure that electrical systems are installed and maintained safely. Follow these guidelines to comply with electrical codes and standards. Firstly, obtain a copy of the applicable electrical code. Secondly, read and understand the requirements of the code. Thirdly, follow the code when installing and maintaining electrical systems. Fourthly, have electrical work inspected by a qualified electrical inspector. And finally, stay up to date on the latest code changes. Electrical testing and measurement are essential for ensuring the safety and reliability of electrical systems. Electrical testing and measurement can be used to identify potential problems before they cause failures or accidents. Several types of electrical testing and measurement equipment are available, including multimeters, which are used to measure voltage, current, and resistance. Clamp-on ammeters, which are used to measure current without breaking the circuit. Insulation resistance testers, or megometers, which are used to measure the resistance of insulation. Ground resistance testers, which are used to measure the resistance of the grounding system. Power quality analyzers, which are used to measure the quality of electrical power. Follow these guidelines when performing electrical testing and measurement. Firstly, use the correct testing equipment for the task. Secondly, follow the manufacturer's instructions for using the testing equipment. Thirdly, wear appropriate personal protective equipment. Fourthly, disconnect the power before testing to energize circuits. Fifthly, be aware of the hazards of electricity and take steps to protect yourself and others. Sixthly, record all test results. And finally, analyze the test results to identify potential problems. Electrical troubleshooting is the process of identifying and resolving problems in electrical systems. Electrical troubleshooting requires a systematic approach and a good understanding of electrical principles. Follow these steps when troubleshooting electrical problems. Firstly, gather information about the problem. Secondly, identify the symptoms. Thirdly, analyze the circuit diagram. Fourthly, use testing equipment to locate the fault. Fifthly, repair or replace the faulty component. Sixthly, test the circuit to ensure that it is working properly. Seventhly, document the troubleshooting process. And finally, follow these tips for successful electrical troubleshooting. Firstly, be patient and methodical. Secondly, start with the simplest possible explanation. Thirdly, check the obvious things first. Fourthly, use a process of elimination. Fifthly, don't be afraid to ask for help. Sixthly, double-check your work. Seventhly, be aware of the hazards of electricity and take steps to protect yourself and others. And lastly, always disconnect the power before working on electrical circuits.